Hello everyone, welcome to my channel. Today we will start with another name reaction, which is Beckmann rearrangement. Here you can see the Beckmann rearrangement. I have done with two name reactions, Grignard reaction and Claisen condensation. So let's move on to today's topic, Beckmann rearrangement. So what is mean by Beckmann rearrangement is when ketoenzymes are treated with acidic reagents like concentrated H2SO4, PCl5, etc., they undergo rearrangement to form unsubstituted amide. This is known as Beckmann rearrangement. So, what is Beckmann rearrangement? It is a when ketoenzyme means what? So, let me show you which is called as ketoenzyme. Here you can see that this is our phenyl group. Okay, so this is bonded to carbonyl group, and again we will have this phenyl. So what is this? So this is our benzophenone. Benzophenone means this comes in ketone family. When you will replace this oxygen with N bonded to hydroxyl group, when you will replace this oxygen with this group, you will be having your ketoenzyme. You will be having your ketoenzyme. So here C6H5 C double bond N, which is attached to hydroxyl group, and here is our C6H5. This is your benzophenone benzophenone oxime, because this is ketone, this is your ketoenzyme, this is your ketoenzyme. Hope you have understood this, what is mean by ketoenzyme. So let's move on. When ketoenzymes are treated with acidic reagents, what you have to take in Beckmann rearrangement is H2SO4, concentrated H2SO4. H2SO4 is an acid. So what acid do? It will donate a proton. Hence, after the donation, it will undergo a rearrangement. Then we will get amide, substituted amide group. Here you can see that this is our benzophenone oxime, which is treated with concentrated H2SO4. Then we will get this benzanilide. Benzanilide, here is, this is our amide group. This is our amide group, which is C double bond O NH. This is our amide group, which is attached to C6H5. Here is another C6H5. This is substituted amide group. This is our substituted amide group. Here you can see that benzanilide, anilide means what? Anilide means what? It is a combination of aniline. It is a combination of aniline and amide. So which group is called as aniline? Which group is called as aniline? So C6H5, when it is directly attached to amino group, this is called as aniline. This is called as aniline. Hence, if this NH, if this NH2 group, which is bonded to C double bond O, that is our carbonyl, and this C6H5, this comes in amide family. Hence, this aniline will be attached to this amide, and this will be known as anilide. So what we have? Benzanilide. What we have? Benzanilide. So let's move on. So you can see this here, carbon is doubly bonded to nitrogen. Carbon is doubly bonded to nitrogen, which is a restricted rotation. We know that when carbon is singly bonded to nitrogen, we can rotate this. We can rotate this, but when it is bonded, doubly bonded to nitrogen, when it is doubly bonded to nitrogen, when carbon is doubly bonded to nitrogen, it is a restricted rotation. We can't rotate this bond. So because of this restricted rotation across a carbon nitrogen double bond, geometrical isomerism arises. So what we will get is two isomers. The two isomers are named as a prefix syn and anti. Syn and anti. We will get two isomers which is named as syn and anti, which also called as Z form. Prefix syn is also called as Z form, and prefix anti is also called as E form. How you can say that this is Z form? Here you can see that this is our restricted rotation. So if you will draw the imaginary line in between this carbon and nitrogen, and you will be giving a number by a priority group. Here you can see that OH will carry 1 because there is no group present over here, but it is hydroxyl group, so we will give 1 to this. And here you can see that there is a phenyl and methyl group, so by giving a priority list we will give this as 1 and this will be 2. So here you can see that this is 1, this is 2. So this, if 1 will be combined to 1 and then this 2, what we will get is Z. What we will get is Z. Here you can see that this is our Z. Hence this is Z form. How you can see this is E form? By again drawing the vertical line in between carbon and nitrogen. This will be numbered as 1 because there is absence of any group, and here you can give 1 to this methyl, 1 to this phenyl, and second to this methyl. Why? Because according to the priority list. Okay, priority group. So here phenyl will be a higher priority than methyl. So here you can see that there is an absence of Z form. There is an absence of Z form because you can't draw this Z form. Hence it is called as E form. Why? Because this is anti. You can see that hydroxyl group and this higher priority means phenyl group, they both are exactly anti to each other. They both are exactly anti to each other. Hence this comes as E form. This comes as E form. This is our Z form. This is our E form, which is also called as anti. This Z form is also called as syn. One thing you have to note down is it has been found that the group which is anti to hydroxyl group migrates. So how will you get your product? There is a rearrangement, means there is a migration of some group. So which group will migrate? So here you have to note down that the group which is anti, the group which is anti to hydroxyl group will migrates. The group which is anti to hydroxyl group will migrates. So we will understand it better by taking a mechanism in presence of H2SO4. H2SO4 is an acid. It will donate a proton. What will this is our ketoxime. This hydroxyl group having a lone pair, it will abstract this proton. Then we will get, this is our R bonded to carbon. This is another our alkyl group, doubly bonded to nitrogen, and then this oxygen is bonded to 2 hydrogen. This will become electron deficient. One thing we know that oxygen can't be electron deficient. It can be electron rich, but it can't be electron deficient. So what we have to do is removal of this water molecule. After removal of this water molecule, we will get nitrogen, which carries positive charge, means nitrogen becomes electron deficient. So what we have to do is we have to this migrate group. This group will get migrate. Why this group migrate only? Because this group is anti to hydroxyl group. Here you can see that this group is anti to hydroxyl group, hence this group will migrate towards nitrogen. So what we will get is R C double bond N bonded to another alkyl group. So we will get our carbocation. Here you can see that carbon becomes electron deficient. So what we have to do is we will take our water molecule which we get earlier. So this water molecule will attack on this carbocation. So what we will have is R C. Carbon will attach to this water molecule. Oxygen will carry positive charge and this group will be as it is. Here you can see that oxygen again carries a positive charge. So what we have to do is make it a neutral. So how you will do that? By deprotonation. So what we will get is R C O H double bond this N and another alkyl group. This we will get. Okay. So what we have in our product is amide. So this is not our amide. How you will get this amide? By tautomerization. Okay. How you will get this? This OH will get a double bond. This OH will be rearranged as a double bond and this double bond will shift towards this nitrogen. So nitrogen will carry a negative charge. So what will this negative charge do? This will abstract this proton. Just see, RC double bond OH. Again this oxygen will carry a positive charge and this double bond shift towards this nitrogen and nitrogen will carry a negative charge. So what does negative charge do? This will abstract this proton and this will shift on oxygen. So what we have is R C double bond O N H R dash. This is our amide. This is our substituted amide group. So this is our N substituted amide. Just remember that what we will have is when you will take keto-oxides in presence of H2SO4, so the group which is anti to hydroxyl group will migrate only, and after the migration what you will have is carbocation. After the migration what will you have is carbocation. So after having a carbocation we will take a water molecule and after the attack this we will get, and what you have to do is make it a neutral. Oxygen make it a neutral. So how you will get this? By deprotonation. So here you can see this OH. So here you have to make it a amide group. So how you will do that? By tautomerization. this OH will shift by making a double bond, and this double bond will shift towards nitrogen. Nitrogen will carry a negative charge. Here you can see that nitrogen carries a negative charge. This negative charge will abstract this proton, hence this bond will shift towards oxygen. So here you can see that RC double bond O, NH, R dash, and substituted amide. This is what we will get. At the end we will get N substituted amide. Just note down that in Beckmann rearrangement, by taking ketoxime in presence of concentrated H2SO4, you will get N substituted amide, and in presence of PCl5 also you will get N substituted amide. Thank you.